Flashback.
Good morning, everyone. Welcome back to Benny and Auto Parts Facebook page. It's been several weeks now since we last reached out to all of our customers and friends and about our services here at the shop. Just a real quick recap. The first segment was about our head department and the different machines in the head department, how the heads are processed through that department from the cleaning to magnafluxing to valve jobbing to resurfacing. We've covered that. Then we jumped into the block department and we covered how we clean the block through the acid dip process, cleaning it, honing, boring, cam bearings, installation of the cam bearings and different things that are affected with the block and how we process those to get them ready for either number one for our customer to build, or number two, it might be something that we're building. So that brings us to our third segment, which is we're going to kind of highlight and talk today about crankshaft balancing once again. Now, we've covered this topic once, and it's been back probably towards the third quarter or so, or fourth quarter of last year. But we're gonna go into that again and answer a few questions that we've kind of get from customers about balancing, about why you should balance. As we talk about this, we're going to incorporate into this a current balance job that we're doing for this highline build on a Boss 302. We kind of told everybody about that build about a month or so ago. We finished up a couple Pontiacs, got those out the door, and our next build is going to be this 302. So we're going to kind of work that 302 build in with this little editorial about balancing, so that you can kind of see. We're going to give you a little bit more in-depth conversation and in-depth of how we do it and why we do it, and kind of show you some videos or some pictures of the crankshaft in its current state right now, and how we're going to go about getting this thing balanced. So the first question we get, I guess is the biggest question: why do you need to balance your engine? Well, if you've got a stock production engine, say from General Motors or from Ford, when General Motors builds that engine, they have the balance of the crankshaft built into the engine. In other words, they use specific weight rods, specific weight pistons, and a specific weight crankshaft, and those crankshafts are designed to work with that combination. So actually, when you buy your vehicle, let's say you bought a brand new 1990 Chevrolet Vortec 350, right? That engine from General Motors has been balanced. It's been balanced at the factory, because the components are built such that the weight of all those components is matched to the crankshaft. So that's why when you buy an engine from General Motors in your vehicle, it's already complete. Now, so you ask, well, then why do I need to balance? Well, you need to actually, what we would really call rebalance, when you go in there and you start changing components. Okay, let's say you have a 350 Chevrolet and you want to make a 383 stroker. Well, when you order a 383 stroker, it comes unbalanced. So you get a set of pistons, you get a set of rods, and you get a crankshaft. Crankshaft would be a 3750 stroke. Well, that crankshaft will come unbalanced, and it will be externally balanced. In other words, the flywheel has a weight on the back of it, and the harmonic balancer has a weight built onto it. So you've got to put those components on it and spin it and rebalance the crankshaft rotating assembly, because number one, it's all new. Now, another scenario would be if you have, let's say you have a performance engine. We'll take this one for example. All right, this is a Boss 302 crankshaft. Now, this crankshaft has already been balanced. David can show you right here. I can show you the holes in it where it has been drilled. and balanced to a rotating assembly once. So you can see here, it's been balanced on the rear. We'll spin it around here, and you can see it's been balanced on the front. Well, what we're going to do with this assembly is the customer has changed the pistons. So once you change the pistons, you've put a new weight, piston weight, into the equation. So what has to happen, the bob weight has to be recalculated, bolted onto the crankshaft, and then we spin the crankshaft with the new bob weight. So while we're talking about bob weights, I'll show you a bob weight. All right, this is bob weight number 1. So on a V8, you have 2 rods per journal. Okay, on the particular one on a Ford, you'll have 1 and 5. Right side front cylinder is number 1, left side front cylinder is number 2. Well, they bolt to the same journal of the crankshaft, so you build a bob weight, and this bob weight will bolt to the journal, and it will serve as the 2 piston and rod assemblies. So I'm going to take this apart real quickly, and I'm going to bolt it to the crankshaft. Of course, this is 2 halves. So this would be cylinder number 1. This would be cylinder number 5. So we're going to put these on. So those will bolt like this. Of course, when you bolt this on, it goes horizontal to the journal. So this particular bob weight is a weight of 1,786 grams. So you divide that in half, so that's 893 per side. In other words, the piston rod assembly for number 1 weighed 893 grams. The piston rod assembly for number 5 weighed 893 grams. So that's why you make this 1798, because you're taking into account both rods, pistons on both cylinders. So that's how the bob weight works. We've got it bolted on, and I'm going to tighten it up. And we do this for all 4 journals. So that's number 1 and number 5. So the next one up is right here. This will be number 2 and number 6. So I've already built the bob weight. So we're going to go ahead and put this bob weight on. First thing I do when I build a bob weight is I weigh everything. I weigh all 8 rods. I weigh all 8 pistons. I weigh 1 set of rings. I weigh the wrist pin, and I weigh the rod bearings. That's how I arrive at the bob weight. Again, I'm bolting this to the 2nd rod journal in the crankshaft. And really, you have to just pay close attention, because you want it centered. You try to center it best you can in the rod journal, and you want it approximately 90 degrees to this one. So we've got this one set. And then we're going to go right on and do the next one. So this will be cylinders 3 and 6. The cylinder arrangement on a Ford is a little bit different than a Chevrolet. On a Ford, the right side of the engine is cylinders 1, 2, 3, and 4. And then on the left side of the engine is cylinders 5, 6, 7, and 8. Once again, I'm getting that centered up. And you always have to tighten them good, because number 1 is you don't want them spinning. As you're spinning the crankshaft, you don't want these to be moving. And you sure don't want one of them to come off. As one of these comes off, I guarantee you somebody's going to have a bad day. and I don't want it to be meat, because I spin this thing about 300 RPM to start with. All right, so now we're going to put on 4 and 8.
And that's a real soft metal, it's not to
It is.
the drum.
It is. These are aluminum, and they're real soft, and they don't do any. They're so soft that they don't hurt the journal at all. And that's designed. They're designed that way. So I can turn them like that, and it's not hurting a thing. Okay, so we have got this. Bob weights are all bolted up. As you can see, they're about 90 degrees apart. This particular assembly it's an external balanced assembly. A lot of people don't understand this about Fords. All Fords, small block Fords, now I'm talking, when I say small block, I'm talking about 351, 302, 289, 260, small blocks, are externally balanced. Well, people say, well, what does externally balanced mean? Well, I can show you. This is the harmonic balancer that goes on this engine. If you'll look right here, you'll see this weight is bolted into this balancer. So that weight is designed to help balance this crankshaft. So if you got 28, these are 28 ounce. That particular one's 28 ounce. This is a flywheel. If you look at the flywheel, it also has a weight built into it right in here. Now that weight on this particular flywheel is also 28 ounces. So you got to match. You got to have 28 here, 28 here. So if you don't match, you're going to have a big balance problem. So you always have to match those up. Now, little tidbit of information for you Ford guys out there. 82 model Ford small blocks and back. In other words, back to 63 or 4, I guess, when, I don't know, 260s came around, about 1960 or so. Those are all 28 ounce flywheel balancer assemblies. 82 back, all of them. 83 forward on Fords, 302s, mostly 302s, 351s at that point. 289 had gone away. Those are all 50 ounce. So that's twice as much weight just about on the balancer and the flywheel. Now, another little tidbit of information. All Ford aftermarket, when I say aftermarket, I'm talking about performance rotating assemblies, Scat, Eagle, Callies, Wiseco, all of them. All aftermarket rotating assemblies are designed to be 28 ounce. That's just the way the manufacturers do. It really makes no sense to have 50 ounces out there turning around. You know, 50 ounces is divided out by 16. You know, that's 3 pounds, a little over 3 pounds. So cut that in half by doing 28. So remember that, all aftermarket rotating assemblies are 28 ounces. So what we're going to do next is the next step in the process is we'll bolt the flywheel to the crankshaft, then we'll install the harmonic balancer on the front of the engine. Now we'll do some time-lapse delay stuff while we're spinning this thing so you can see it. So one last thing I want to show you while we're talking about balancing is if David will come over here, I want to show you a bob weight card. In other words, this is how we come up with this number on these bob weights. So this is the computer right here where we build our bob weight card. We call it a bob weight card. It's not a card anymore. You used to have to write it all down, but now it's all done in the computer and stored as you do it. So we're going to start out with the rod. All right, first thing I weigh is the rod. So I've got a scale right here. This scale is connected to the computer, and we weigh the rods on the scale. So the first thing the computer figures based on the weight is this weight of the big end of the rod. These particular rods on this particular application were 432.3 grams. On the small end, which is the pin end where the wrist pin goes through, it was 174.8. So you can see it right there. So there it is right there. The total weight of the rod was 607.1. So that is recorded, okay? Big end is on this side of the bob weight card. The small end of the rod, piston at the top of the rod, everything at the top of the rod is on this end. So the second thing we weighed was the piston. Piston was 481.9, so we recorded that. The next thing we weighed was the customer's piston pin, the pin itself that connects the piston to the rod. It was 130.2 grams. So we got that. The next thing we weighed was the lock. This is a floated rod assembly. In other words, the piston and pin float in the rod, so it has keepers on both ends. So the lock, we call it, it's the wrist and pin lock, 2.2 grams. So we record that and send it. All right. The next thing we do is we weigh all the rings. We weigh the rings for one piston. In other words, we weigh the top ring, the second ring, the oil ring, all three pieces of the oil ring, and in this particular application, it has a support rail that was in the oil ring, so we weigh the support rail as well. That figure was 50.2. So we've got all that recorded. So we got everything on the right side, 839.3. So now we come over to the other side. We weigh the rod bearing. This particular bearing weighed 38.8 grams, so we did that and recorded that. So then we got the times rod throw times 2. In other words, that 2 means there's 2 rods per rod throw rod journal on the crankshaft. So that's recorded. That's an automatic right there on a V8. Now, if you were doing a 4-cylinder inline or 6-cylinder inline, that number right there would be 1, because there's only one bob weight, 1 rod per journal. And then the last thing we do is the oil. We allow 4.0 grams, 4.0 grams for the oil. So you add all this up, you come up with your bob weight. This particular one came up at 1785.4. So half of that is 892.74. So we rounded this from 1785 to 1786, rounded it up. And then, of course, half of that is one side, the other half is the other side. This is how we make we come up with our bob weight that we make and put on the crankshaft. So that's what it is. This is the spin screen. Once we get the balancer on it, once we get the flywheel attached to it, we will set this we'll start it at 300 RPM. And that's where our first spin will be. We look for, we try to get it down to 2 ounces on the initial spin, and then after we get there, we do a final spin of 500 RPM, and the 500 RPM in the mathematical equation of the computer is equivalent to about 6,000 RPM. So, of the actual running in the engine. So, I hope that answers some questions that everybody's had about engine balancing. Just real quickly, a recap. Anytime you change the equation in the rotating assembly, in other words, the weight, you have to rebalance. Anytime you order a new rotating assembly that's unbalanced, you have to balance the assembly. And people say, well, what good is it? Well, I'm going to tell you, it saves, the main reason is you balance is it saves engine bearings. It saves your mains, cuts down on the harmonics or the vibration. You know, a lot of times if you crank an engine that's unbalanced, if you're in the car, you can feel it. You can feel it in your feet. You can feel it sometimes in the steering wheel because it's such an unbalanced assembly. It shakes. Shake is not good. You want to reduce or minimize as much engine shake, or the correct term is harmonics, frequencies. So you want to reduce that. And of course, once we spin this, we'll actually get this down, hopefully less than 2 grams. Don't know what it's going to start out at. We'll show you once we get it spun up. And one last thing, this is the probe right here. This is the sensor. This sensor goes on the very front of the crankshaft after we get the balancer installed. Put the bolt in it. This will attach. It's magnetic. It attaches right here. And this is the sensor that sensors the frequencies of the crankshaft unbalanced, sends them through the sensor right here at the back, and then it records it in the computer. So that's how we work down to our final number. So I hope you've enjoyed this. We'll do a little bit more follow-up as we move through this balance right here on this Boss 302, and we'll keep you updated on this build as we start moving through it. Looking forward to the build. It's a kind of a rare Ford engine. You don't see a whole lot of them. I think I've been doing this now for 18 years, and this is the first Boss 302 we've actually built. So we're looking forward to it. Hope you'll stay tuned. We'll keep you abreast of it, up to date as we move through it. So once again, I hope this answers some of your questions of why you balance and what could happen if you don't balance. I've actually seen, and I'll leave you with this thought, I've actually seen a 400 Chevrolet that was so out of balance that it broke the transmission off the back of the engine. That's how out of balance it was. And after we got into it and got to looking, trying to determine why it did that, we found that the customer, when he installed the engine, had the flywheel indexed in the wrong position. Instead of the weight being down here, it was 180 degrees out up here. So it was just shaking itself apart till finally it shook so bad it broke something. So we don't want that to happen. We're here to stop that. We're here to help you with any balance issues that you might have. So we appreciate you tuning in. Look forward to seeing you on the next phase of the 302 build. Have a great day.